Right, so now we're going to do method 3 to prove, use method 3 to prove a figure is a parallelogram. Right, and method 3 was showing both pairs of opposite sides are equal by calculating the distance of all four sides. All right, so step number 1 is the graph. Right, and I'll just move these away and I'll put them back. Whoops, well now I messed that one up. We'll just remember that that's not right. Probably anyway. All right, so we're going to graph our 4 points, -2, 3, and so you'll do the same thing because it's in your notes, and then 4, 3. So let's label that. That's L, that's M. N is 2, -2. And O is -4, -2. All right, and now we'll connect. When you connect, you go start with the first point and connect to the next. So L, then M, and then from M, go to N. And then from N, go to O. And then from O, go back to L. Let's see how off this is. Oh, wow, look at that. I got it in the right length, pretty much. Just a little bit facing the wrong way. All right, and then from O, go back to L. And there's our figure. So that's our step number 1. Step number 2 is what do we want to show? We want to show both pairs of opposite sides are congruent. And I do want you to write it, what you want to show, even though it's in the question, because we need to focus on how we're going to do it. Sometimes, and maybe you're not told what way to use, right? And then you have to decide which of the 4 methods, right? Our formula is already written in there for you. So step 3 is the formula, but that's already there. So we don't have to write it again because it was already put in there. Now step number 4 is the work. All right, so we're going to use the distance formula to calculate out all 4 sides. So LM, right, so the change in the x value, so we have, we're going to subtract the x's, -2 minus 4 squared, plus subtract the y's, 3 minus 3 squared. All right, well, that's going to be the square root of -6 squared. So -6 squared, and we don't need, well, I'll put that in. It's plus 0. 3 minus 3. I'll write it in just so you see if we don't really need it. So -6 all squared, right? The whole difference is squared, plus 0 squared. Well, 0 squared is 0. So that's going to be the square root of -6 squared is positive 36, and the square root of 36 is 6. And of course it's going to be 6. It's a horizontal line. And if you realized, hey, 1, 2, 3, 4, 5, 6, it's a horizontal line at 6. Right? Or you just took the difference in the x coordinates and took the absolute value of the difference in the x coordinates because it's a horizontal line, that would be okay. And then we'll find, let's find the opposite side. So let's find ON. All right, so difference in the x's, -4, and n is is 2. There it is, sorry. -4 minus 2 squared plus, and then -2 minus a -2, which is really -2 plus 2. So that's going to be the square root of -6 squared plus 0 squared. Well, that's just the square root of -6 squared is positive 36, and the square root of 36 is 6. All right, so but if you just took the absolute value of the difference in the x-coordinates because it's a horizontal line, or counted because it's a horizontal line, that would be okay. But of course you can't count for the diagonal lines. So, and I figured we need to practice with distance formula anyway, so I did it on the horizontal lines too, but we definitely need it for the other two sides, which are LO and MN. So LO, take the difference in the x-coordinates, right? So that would be -2 minus a -4 squared plus, and then 3 minus a -2 squared. So -2, that'd be -2 plus 4, so that's going to be 2. So we have the square root of 2 squared plus 3 minus a -2 is 3 plus 2, so that's 5 squared. And that would be 4 plus 25, which is the square root of 29, which does not simplify. That's a prime number. And I need to squeeze in one more side. So I am going to move all of that up because if I move that up there, and you know what? I can just squeeze the one other side in right there. And you do what you need to. To squeeze it in, but we need MN. All right, so 4 minus 2 squared plus, now difference in the y's, 3 minus a -2. Be careful with your signs, that's where you can make errors. 4 minus 2 is 2. And -3 minus a negative is the same as 3 plus 2. So that would be 5 squared, which would be the square root of 4 plus 25, which is the square root of 29. All right, so now we're going to do this one as a paragraph proof. All right, and part of it's written for us, and then we'll fill in the rest here. All right, so since let's start with the sides we started with first. So we started with the LM and the ON. Since LM, that should be a segment, right? Because it stops, has endpoints. Since LM is congruent to ON, and how do we know? I'm going to put it in parentheses because otherwise my sentence is going to be a really wrong run-on sentence. That's why I find the hardest thing about the paragraph proofs is making a sentence not be a run-on sentence. So since LM is congruent to ON, actually I just won't put the amount in. We'll just put using the distance formula. Using the distance formula, and what are the last two? MN is congruent to LO using the distance formula. Ooh, running into one another. LMNO. That's actually a very bad sentence because I have since. Well, just get rid of the therefore. Then I'll have a good sentence. Since LM is congruent to ON using the distance formula, and MN is congruent to LO using the distance formula, LMNO is a parallelogram because it is a quadrilateral with two pairs of opposite sides that are congruent. There we go. So you can tell that I prefer the two-column proof because I don't have to worry about writing good sentences that aren't run-on. Are congruent. All right, there we go. All right, but so long as you have the information you need and it's connected, it's okay if your sentence is maybe not the best sentences. All right, I'm not judging you on how well you write a sentence. I am judging you on how well you justify what you're saying. All right, and we included our formula. We gave the necessary information that we had the two pairs of opposite sides that are congruent. We show our work, right? And we justify that LMNO has to be a parallelogram because it's a quadrilateral and it has two pairs of opposite sides that are congruent. And that is one of the ways, right, that we can prove a quadrilateral is a parallelogram. All right, I'm going to end this one, and then I'm going to add, we're going to have one more, we have one more parallelogram proof. All right, bye for now.